You think Caribbean pirates lived in tropical paradise with perfect weather and gently ocean breezes.
But here's the shocking truth that will shatter every romantic pirate movie you've ever seen. Extreme tropical heat killed more pirates than sword fights and cannon battles combined in Caribbean waters.
Temperatures that could literally cook human brains inside skulls weren't just uncomfortable, they were death.
Sentences that could turn strong, healthy pirates into delirious corpses within hours of extreme exposure. Hollywood has completely lied to you about pirate life in the Caribbean with fantasy weather. Those movies showing pirates casually sailing through paradise weather in heavy coats are pure fantasy. Real pirates faced brutal tropical heat that transformed wooden ships into floating solar ovens, where metal cannons became too hot to touch and deck planks caused third-degree burns. Most successful pirate crews weren't just skilled fighters who could win battles under perfect conditions. They were heat survival experts who developed life-or-death cooling techniques for extreme temperature management. These weren't just comfort measures for dealing with warm weather during pleasant tropical voyages.
These were sophisticated thermal management systems, meaning the difference between legendary careers and heat stroke death.
Here's the horrifying reality about extreme tropical heat that every experienced pirate learned to fear.
More than enemy weapons, because wooden ships became floating death traps in Caribbean sun.
With surface temperatures reaching levels that could cause severe burns on contact during peak hours. Metal cannons and ship fittings became dangerous hazards that could burn flesh instantly when touched. Pirates learned to avoid direct contact with metal surfaces during hottest parts of day, because even brief contact could cause serious injuries that would become infected and fatal. Deck planks would reach temperatures that made walking barefoot impossible, forcing protective footwear usage. The wooden surfaces pirates lived on daily became burning hot platforms that could blister skin.
Interior ship temperatures reached levels that made enclosed spaces completely uninhabitable during peak heat.
Pirates couldn't retreat below deck because ship interiors often became hotter than exposed areas, creating greenhouse effects that trapped heat and made enclosed spaces deadly rather than protective. Air temperatures combined with humidity to create heat index readings exceeding human survival limits,
making it physically impossible for bodies to cool themselves through normal sweating and regulation.
Pirates would face conditions where their natural cooling systems completely failed, leaving them vulnerable. Solar radiation from direct sunlight and water reflection created double exposure, causing severe sunburn. Pirates had to deal with heat sources from multiple directions simultaneously, making shade inadequate. Medical consequences of extreme heat exposure created cascading health problems that could kill pirates, even after temperatures decreased, because heat stroke could cause permanent brain damage and death. Dehydration accelerated rapidly in extreme heat, causing pirates to lose dangerous amounts of fluid through sweating, while simultaneously making it difficult to keep replacement fluids down completely. The cycle of fluid loss and replacement failure could kill healthy pirates within hours. Medical reality of heat stroke was absolutely terrifying for pirates watching healthy crewmates transform into delirious invalids within hours of extreme temperature exposure that could prove fatal quickly. Heat stroke could cause brain swelling, organ failure, and death through rapid, agonizing processes. Core body temperature elevation caused proteins in blood and organs to literally cook inside living bodies, creating irreversible damage that could kill even when heat exposure ended completely. Mental confusion and delirium from heat stroke made affected pirates dangerous to themselves and crews,
causing them to make fatal mistakes while being unable to recognize their own impaired condition.
Circulatory system failure caused by heat stroke could kill pirates through heart attacks and strokes. As cardiovascular systems became unable to cope with demands of extreme temperature regulation completely. Cascade of organ failures from severe heat exposure created multiple simultaneous threats to survival, with kidneys, liver, and brain all failing, while victims remained conscious of approaching death. Recovery from heat stroke could take weeks, leaving affected pirates as burdens on crews. Heat stroke victims often never fully recovered their previous physical capabilities, ending pirate careers.
The nightmare of engaging in deadly combat while dealing with extreme heat created impossible situations.
Picture trying to fight enemy ships while wearing heavy clothing in temperatures making thinking impossible.
Combat effectiveness disappeared when heat exhaustion made pirates unable to aim weapons accurately or move.
Heat-impaired pirates would drop weapons, miss targets, and make tactical errors, resulting in death. Heavy clothing and protective gear became death traps in extreme heat, forcing impossible choices between protection from enemy weapons and protection from deadly temperatures that could kill faster.
Physical coordination deteriorated rapidly when extreme heat affected motor control and balance during combat,
making it impossible to climb rigging, handle weapons, or perform complex physical combat tasks. Decision-making abilities became compromised when heat affected brain function, causing fatal tactical errors completely.
Move the troops north! No, we must head south!
Weapon handling became dangerous when extreme heat made metal weapons too hot to hold, while simultaneously impairing motor skills needed to use them effectively during crucial battle moments. Enemy advantages increased dramatically when opposing forces had better heat management strategies than pirates. Most tragic pirate defeats occurred when crews that might have won battles were heat weakened. These men would face enemies while suffering from heat, exhaustion, making victory impossible. Smart pirates realized controlling heat exposure required sophisticated engineering solutions beyond simply seeking shade. They developed elaborate sail-based cooling systems, creating comfortable working environments during extreme temperature conditions. Strategic sail positioning became crucial skill, involving understanding sun angles, wind patterns, and orientation.
Pirates learned to predict how sun position would change and arrange shade systems accordingly.
Spare canvas deployment created additional shade surfaces that could be rigged quickly during emergencies. Pirates would maintain inventories of extra sail material specifically for heat protection during temperature crises. Multi-layer shade systems provided more effective cooling than single canvas covers through air gaps. That allowed heat dissipation while providing multiple barriers against harmful solar radiation from above. Adjustable rigging systems allowed pirates to modify shade structures throughout a day as conditions changed. These systems required sophisticated rope work, but provided dynamic cooling that adapted automatically. Ventilation integration combined shade structures with wind management to create cooling systems using circulation.
Pirates learned to position shade systems to capture cooling breezes while blocking solar radiation.
Reflective surfaces made from polished metal could redirect harmful solar radiation away from work areas.
Pirates would use mirrors, polished weapons, and reflective materials to create cooling through solar engineering.
Communal cooling areas provided protected spaces where entire crews could retreat during peak heat.
Creating shared refuges that allowed coordinated rest and recovery during dangerous temperature conditions, completely. Water cooling represented ultimate heat management technique, but required careful conservation of precious supplies. Pirates developed sophisticated methods for using minimal water to achieve maximum temperature reduction effectively. Wet cloth cooling systems used minimal water to create maximum cooling effects through evaporation. Evaporation cooling techniques created primitive air conditioning systems using wet surfaces and wind patterns. Pirates would create cooling zones using wet canvas and strategic airflow, lowering temperatures significantly. Strategic water placement involved using precious fresh water supplies to create cooling without wasting liquid. Pirates learned to position small water amounts where evaporation provided maximum cooling for crews. Seawater cooling applications used abundant ocean water for external cooling while avoiding consumption dangers. Pirates would use seawater for cooling cloth and creating evaporation systems without depleting supplies. Water conservation techniques ensured cooling applications didn't threaten crew survival by depleting drinking water. Pirates developed methods for recycling cooling water and maximizing effectiveness while preserving essential drinking supplies. Emergency water cooling protocols provided life-saving temperature reduction for heat stroke victims using available water. Even when supplies were critically low and pirates learned to prioritize water for emergency cooling. Human element was absolutely crucial for heat survival because some pirates possessed natural tolerance
and developed expertise, making them invaluable during extreme temperature emergencies, threatening crew survival completely.
Former desert dwellers and tropical natives brought professional knowledge, proving essential for surviving extreme temperatures.
These individuals often became heat management specialists, combining natural tolerance with learned cooling techniques.
Physiological adaptation allowed some pirates to function normally in temperatures that incapacitated other members, making them natural leaders during heat emergencies when normal command structures broke down completely. Heat tolerance training helped pirates gradually build resistance to extreme temperatures through controlled exposure, and conditioning that improved their natural cooling abilities through experienced pirates learning systematic adaptation.
Inflame. Emergency response skills enabled heat warriors to recognize and treat heat stroke symptoms quickly,
providing life-saving intervention when crew members succumb to extreme temperatures, requiring immediate medical attention.
Leadership during heat emergencies required special skills for maintaining crew morale when temperatures made activities possible, while heat warriors often became temporary commanders, organizing cooling efforts and crew safety. Teaching and knowledge transfer abilities allowed heat specialists to share expertise with other crew members,
creating backup heat management capabilities, ensuring cooling knowledge wouldn't be lost when specialists unavailable.
When conventional cooling methods weren't sufficient for treating severe heat stroke, desperate pirates turned
to increasingly disgusting but potentially life-saving emergency treatments preventing death from extreme temperature exposure. Urine cooling applications used readily available bodily fluids to create emergency cooling when water unavailable.
Pirates learned urine-soaked cloth applied to head and neck provided crucial cooling during emergencies.
Bilge water cooling used ship's wastewater mixed with organic matter to create cooling baths that could reduce body temperatures rapidly through these revolting mixtures, providing full-body cooling effects.
Saliva cooling techniques used concentrated bodily fluids to provide cooling for specific body areas. When other liquids weren't available, and pirates would use saliva-soaked cloth for cooling pulse points.
Vomit and waste cooling involved using any available bodily fluids for emergency temperature reduction. When heat stroke threatened immediate death, and these applications provided life-saving cooling despite disgust. Food waste cooling used rotting organic matter mixed with liquids to create cooling applications. Pirates would use spoiled food and kitchen waste, creating cooling mixtures when clean materials unavailable.
Animal waste cooling involved using any organic materials that could provide cooling effects through moisture.
Pirates facing death from heat stroke would use literally any cooling method that might save.
Blood cooling used fresh blood from injuries to provide cooling liquids when other options unavailable.
This was extreme emergency measure, demonstrating how desperate pirates became when facing heat death.
Transformation of pirate operations from diurnal to nocturnal represented one of most significant adaptations.
To extreme heat, fundamentally changing how pirates worked, fought, and lived in tropical environments.
Night operations became the only safe way to conduct business when daylight temperatures exceeded survival limits.
Nocturnal work schedules allowed pirates to perform essential ship maintenance during cooler nighttime hours.
They learned to reverse daily cycles, sleeping during deadly daytime heat and working during darkness.
Tactical advantages of night operations included stealth capabilities, making pirate attacks more effective while avoiding
heat-related combat disadvantages that daylight operations created during extreme temperature conditions affecting fighting ability. Navigation challenges required pirates to develop night sailing skills and celestial navigation techniques for darkness. They had to master star navigation, night vision techniques, and darkness sailing most sailors avoided. Combat effectiveness improved dramatically during night operations, when pirates could fight without heat-related impairment, while potentially catching enemies who weren't adapted to darkness combat, like experienced pirate crews were. Sleep management during extreme heat required pirates to create cooling systems, allowing rest during blazing. Daytime hours when work was impossible, and they developed daytime cooling techniques, providing temperature reduction. Coordination difficulties arose when night operations required different communication methods functioning effectively in darkness. Pirates had to develop night coordination techniques, allowing complex operations without visual cues that daylight provided.
Equipment adaptation involved modifying tools, weapons, and ship equipment to function during night operations.
As we reflect on tales of thermal warfare, something profound emerges about human adaptation to extreme environmental conditions that pirates who mastered heat survival weren't just criminals living.
In hot places, they were thermal specialists, functioning in temperatures exceeding normal survival limits.
Techniques pirates developed represented some of most advanced thermal engineering of their era, completely.
Their understanding of shade systems, evaporation cooling, and physiological adaptation informed heat management practices
that influenced tropical survival techniques for generations through practical discoveries emerging from life or death necessity. Most remarkable was how extreme heat became crucible, separating weak pirates from truly hardened survivors.
Caribbean sun didn't just provide weather challenges, it became selection pressure, creating subspecies
of human being adapted specifically for tropical survival under conditions killing ordinary people completely.
Social structures around heat management showed pirates at their most cooperative and mutually supportive always.
Heat survival became community effort, transcending normal pirate hierarchy, because everyone understood temperature management. required collective action and shared knowledge for entire crew survival during extreme weather conditions. Innovation and problem-solving abilities revealed remarkable engineering capabilities that modern thermal management specialists would respect. They created sophisticated cooling systems using primitive materials and intuitive understanding of thermodynamics effectively. Physiological adaptation successful heat pirates achieved represented genuine evolutionary pressure in action, creating human beings
who were physiologically better adapted to extreme temperatures than their European ancestors through environmental pressure.
Leadership and teaching around heat management created informal schools of thermal survival, preserving life-saving knowledge.
Heat warriors became teachers who passed expertise to new generations of pirates facing environmental challenges. Pirates who mastered extreme heat survival understood something fundamental about human adaptability and capacity. To not just endure, but thrive in hostile environments through learning that surviving paradise required becoming tougher than very elements that made their world both beautiful and deadly. These masters of tropical seas proved human beings could adapt to any environmental challenge when survival demanded it, transforming themselves into heat-adapted specialists functioning in killing conditions. Extreme heat became fire that forged steel, creating pirates literally tougher than environmental forces. They learned true mastery meant becoming more resilient than very elements threatening destruction. Proving human adaptability could overcome even most extreme natural challenges when survival demanded evolutionary-level adaptation. Pirates became living examples of rapid human evolution in response to extreme environmental pressures. Their heat tolerance techniques saved more pirate lives than any weapon or tactical advantage.
They ever developed through understanding that temperature management was more important than fighting.
Pirates learned that mastering invisible environmental threats was more crucial than mastering visible enemies. Their greatest victories were often achieved through successful heat management rather than successful battles.
Heat survival techniques became foundation for long-term pirate success, enabling extended tropical operations.
Pirates who mastered extreme temperatures could remain active indefinitely, making them nearly impossible to defeat through environmental warfare that worked against less adapted crews and forces. Their cooling techniques represented ultimate triumph of human intelligence over environmental challenges and limitations.
Pirates became living proof that survival instinct could drive rapid physiological adaptation to hostile environments.
When faced with choice between adapting to extreme conditions or dying from environmental exposure, their techniques showed human beings were capable of evolutionary-level adaptation when alternatives were death. Pirates demonstrated that environmental mastery required becoming more resilient than natural forces trying to kill.
Their success came from understanding that survival meant conquering environment rather than being conquered.
Pirates learned that true environmental mastery meant becoming predators who could thrive where others died. In the end, extreme heat became their greatest teacher, forging humans tougher than nature itself.